All right. Okay, so here's what I'm doing. I have been working on a banner board for a event, and this is what I started with. There's two 8x32 matrices here, and what I wanted to do is, if you've ever seen Price is Right, where they spin that wheel, we want to do something like that, so that colors come across kind of like a spinning wheel, and you'll hit this big red button here to stop it. But things are a little too slow for my liking with this matrix. So what happens is, these are WS 2812B individually addressable LEDs, neopixels. And every single one of these is basically controlled by a digital signal. So on this green line here is your digital data in, and then you have your power and your ground. And so what happens is, when you want to animate something, the data gets pushed through the entire matrix before you can refresh, say your first pixel again. In this case, the first pixel's here in the top right. So the more pixels you have, the slower overall your animation is going to be. And I want something that spins relatively fast. I want to add a potentiometer to it. One of these to be able to control the speed of the basically spinning wheel effect. But it's so slow at its fastest speed that that's really not viable with the matrix as it is. Now, I want this same overall size as a footprint. So physically, I want the board to be at least this big to attract people. So this is going to be used at an event where there's going to be a lot of people walking around, like a convention. And even though I could get almost the speed I want out of just an individual 8x32 matrix, it's still not quite fast enough, but the footprint overall would just be too small. So instead, what I've done is I've purchased these 8 individually addressable strips. So I've purchased these individually addressable strips. So they're the same LED at 2812B, but they come in, I think these are 16 feet or 5-meter strips. Basically, there's 300 LEDs. So this is the 30 density instead of the 60, meaning there's, I think it's 30 LEDs per meter instead of the 60. And what that should allow me to do is create a matrix with the same overall size, 1, 2, 3, 4, 5, 6, 7, 8, but far fewer pixels. So I could even add a couple rows here, but the fastest speed that I was getting out of the even individual matrix was like that, right? So that was with 256 pixels on a 8x32 matrix. So this, what I'm going to do is an 8x20 matrix. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So there's 160 pixels here, if I'm doing my math right. And that is significantly less than the 256 from an 8x32. What I'm also going to do is use just the middle 6 here. So I'm going to take away 40 pixels. So there's just 120 pixels here in the middle on one data line, and then the other data line, I may do one data line for the top and one for the bottom, or I may do one for both the top and bottom to further speed it up. So what's going to happen is the colors, think of them as long rectangles, will speed through the middle here, and then across the top, bouncing back and forth, will be kind of like a Knight Rider effect. And when you hit the button, so we'll have two potentiometers to start with. So I'll put two of these on here, and one of the potentiometers will control the speed of this, while the other one controls the speed of the selector. And then the button, when you stop it, will stop both the wheel and the sliders. And so what you'll wind up with is like two bright blue LEDs kind of showing what color you've landed on. And then a person will just be around to kind of translate that. In the future, I'll probably go back to the matrices, the high density ones, and I'll probably use bigger Arduino with more GPIO and drive by smaller matrices like 8x8, and then drive each matrix with a individual data line, allowing a lot more speed. But the libraries that are out there today don't really have something like that set up to make it easy. So I'd have to write a lot more code, and I'm just not at that point right now, time-wise. I'll probably start that at a future point a month down the road. So what I need to do now is basically solder up these connectors to the ends of these strips, and then I'll connect the middle 6 and the top and bottom, and we'll start coding. So I'm guessing this will take anywhere between 40 minutes and an hour to do the soldering. So it's not going to be too exciting for the next hour. I'm going to stop. I think I'm going to stop the feed now. I'm still kind of working this out. So leave the description as a video up, and then I'll probably start another stream where I'm just soldering, or I'll do a time lapse or something like that. And then I'll get to like a coding stream or something by the end of today. So basically, I'm going to be online. I'm going to be live streaming most of the day, assuming I can keep power to my GoPro here. And it'll be exciting at various points. So I have the chat screen up on YouTube. I'll be watching, so if you have questions, ask there. And check in throughout the day if you're interested in progress. And yeah, so I'm just going to leave this up, I guess. Okay, so I'm going to arrange these in what's called a zigzag pattern. So first, every one of these I'm going to do on they're directional. So I don't know if you can see, there's an arrow at the top where it says ground, or the data just goes this way, ground goes this way. So every single one of these I'm going to do a male connector on the inside and a female connector on the out end. And then I will arrange them in what's called zigzag. So every consecutive row, so this one, the data flows this way. So both of these right now, the data flows the same way. They're both going to flow this way. The bottom one, I'm going to rotate 180 degrees so that I have a male and female connector over here that are easy to hook up. So that's what we'll be doing once we get all these soldered up. But first, let's get to soldering. Yeah, you can see King of the Hill in the background too. Okay. I probably should do music or something, but whatever. Let's see what tip I want. Let's see, what tip do I want for this? I'm going to use a small chisel tip for this. Kind of new to soldering here, so this may or may not go well. see, this is the female side. I think I might grab a flux pen here. So this is a flux pen. I'm just putting some liquid flux down. I think what I'm going to try to do is reflow. So I'm going to put flux down on each of these pins first, or solder down on each of these pins first, and then reflow the solder onto the wires to complete the connection. Let's see, I am using, so I'm going to set my iron at 680 degrees Fahrenheit, and I am using silver bearing solder. So this is some really thin stuff. 62 36-2, and it's 0.022 inch diameter. So this is what I'm going to use. Okay, so I got my solder on there. Now I'm going to try to reflow. This is the part that I'm new to, so okay. So this is my first one, and I think it actually looks pretty good. I don't know how well you can see that. There's a delay on my camera, so I can't really check it, but everything looks clean to my eyes. No shorts that I can see, so I'm gonna flip this around and go for the female side. Actually, I'm gonna grab a drink first. Okay, so I just realized something of a problem. I need to decide right now if I want the plastic on here for this or not. It's going to be difficult to add later. Actually, it should be impossible to add later. Screw it. We're going to go without the plastic on this. I don't like this joint. Okay, that looks better. Alright, so that wasn't bad. It's our first finished strip. So I'm just going to do all these and then test them. I may actually do some heat shrink next time if I do this sort of project again. So this is rosin core solder, so there is flux in it, but I saw a tip on YouTube from the EEV blog guys about using the flux pen and helping with it just helps like get your pads, and it helps with reflow. So all I'm doing here is putting the tip on the pad, heating the pad, and then just putting a little bit of solder on there and letting it flow to cover the pad. Okay. And that one looks pretty good, I think. Maybe this top joint again, a little bit better. That's better. Looked pretty good, but now it looks grand, so that's what we got. I'm gonna switch her over. This just makes, I need a new chair. This just makes my back feel awesome. That's a lie, I don't need a new chair. I need to get rid of this beer gut. Looks good. I do not like that one bit. The only thing I don't like about these connectors is that they are not solid core. I probably should tin the tips of these. Two out of 8 done. This one already has some solder on it, so let's see. So we need a male here. Don't even have to. Still gonna hit it with the flux pen.